Amory, it's great to have you in Australia again. I know you've been here many times before, and you've been very influential in this area since probably 1970s, and you certainly had an influence on my career over the decades. How did you get into this whole energy efficiency space in the first place? What was the burning platform that got you?
Well, when the oil embargo of '73 broke on the world like a thunderclap, I'd already been thinking for a while about energy and realizing that it was a sort of master key for unlocking the tangled issues of resources, security, environment development, economy. And it became obvious in the early '70s that most of the energy we use is wasted, and correcting the waste would be a much simpler solution than increasing and cleaning the supply. Of course, now we get to do both, and the clean supply is growing exponentially. It's just off the charts how fast it's going. Nobody can keep up with that speed. But we're starting to realize that most of the energy we use is still wasted, and that saving most of it is cheaper than we thought. In fact, even cheaper than the very cheap supply now from solar and wind. So that combination is a winner, and if we get serious about doing it quickly rather than having it done to us by others, it could be the foundation of a much more productive, competitive economy. We'd be fairer, richer, healthier, safer, and life would be a lot more fun.
And do you think people really understand the scale of inefficiency? Because I talk to people often. They say, "Look, electric vehicles are so efficient. We've really done that thing for transport now that we've electrified it." And I keep thinking, look, is it really efficient when you've got 2.5 tons of car to move 100 kilos a person?
Exactly so. And if it were properly designed, it would weigh about 350 to 700 kilos. And be safer and a lot more fun to drive. In fact, if you make cars lighter and more streamlined, you can make an electric car 2 or 3 times more efficient than the ones on the road now. In fact, even a bit better than that. So I work with a couple of little companies whose electric cars, just getting ready for mass production now, are so efficient, like 3 times Tesla efficiency, that they don't need to plug in for ordinary daily driving. They can run just off the 3 to 5 square meters of solar cells on the roof. Well, does this matter? Yes, the utilities think tank in the US, Electric Power Research Institute, just put out a paper saying that if we make our electric vehicles just twice as efficient, very straightforward, that would save about $200 billion a year and in the US by avoiding the electrical supply and the charging infrastructure, which could be, would charge faster and could be shared amongst more vehicles, because they would have they would have only half the batteries for the same range. That also makes the vehicles much more affordable because the batteries are the costliest part of an electric car.
I've been watching people's response to your integrative design, and I think it's a combination of sort of amazement and dawning of the obvious. But how do we get people to focus on the actual task that energy is being used for, in terms of how, as a starting point? Because everybody seems to do everything the opposite way, and I've been trying on this energy productivity jaunt for the last 30 years, and it's really quite difficult to get people to actually start with the task.
Yeah, what do you want the energy for? Hot showers, cold beer. Actually, I thought this up when I was living in England, so it should have been, cold showers and warm beer, I suppose. But smelted alumina, baked bread, comfort, mobility. These are the services that the end-use tasks that we want energy for. Nobody wants just lumps of coal or barrels of sticky black goo or raw kilowatt hours. You want the things that it can do for you. And then it makes sense to ask, well, how much energy, of what quality, at what scale, from what source, if used in a way that saves money, is going to do each task in the cheapest way? That's a very different question, and it gives a completely different answer. It tells you that we ought to be using renewable, benign, available sources that can give us a highly resilient supply and not cause pollution, not cause climate change, and give us just nothing to worry about.
Yeah, we still have a lot of that sort of supply side led thinking in Australia. Like everyone's talking about the massive amount of transmission that they want to build to support electrification and renewables. Do you think that there might be an opportunity to cut back on some of that centralised infrastructure if we got the efficiency side right?
Very much so. Using electricity efficiently, many times more efficiently, is on the cards and very profitable to do, and making it nearer where you use it, like the 30+% already made on rooftops. That is resilient. 98, 99% of the power glitches originate in the grid. So if you don't need to haul electricity hundreds of kilometers, there's a lot less to go wrong. It's just coming off your roof. And my house hasn't had a power failure in about 28 years for that reason. So right-sized supply that is near where you need it and efficient use both displace long-distance transmission. And this is already a major trend. Europe is expected to cut the median size of power plants over the next couple of decades by about 95%, and 2/3 of the power supply will feed directly into the distribution system without needing the big transmission wires. That said, there are also some advanced transmission techniques that can make the task of debottlenecking the grid much easier. And just yesterday in the U.S., the Federal Energy Regulatory Commission announced new rules that say you have to consider those new methods. For example, one that we're actually advised the maker of the technology, so I'm not independent on this one, has a new kind of power line that can carry several times more power on a wire, and you can put it in with standard tools and equipment and skills on the existing pylons. So you just reconductor the pylons you've already got, but you get several times more power transmitted over it, and with only half the loss, so the economics are very good. And that will often be able to decongest the grid enough to put in renewables that are now blocked from access without having to do a whole new right-of-way that gets in the way of farmers and causes conflict.
The renewables are getting much cheaper, and I've heard people say as we're starting to electrify everything, that renewables are so cheap, and solar is particularly so cheap, that we don't need to worry about energy efficiency of buildings anymore, that we just put in more renewables as much as we need, and then even if you've got the house that's like a tent, you just put in air conditioning and run. So what's your thought about this sort of?
That's a very expensive
electrify everything
approach. Well, first of all, you don't electrify quite everything because, for example, there's a lot of industrial heat that can be done directly with solar steam, for example, and that now goes up to 500 degrees and very soon 1,000 degrees. So that'll run most industrial processes more efficiently than even a heat pump using electricity. But this notion that renewables are so cheap, you don't need to use them efficiently is actually not correct. Yes, they're very cheap compared to fossil or nuclear. However, you still need to deliver them, which is most of the cost, and efficiency is even cheaper. In fact, a lot of efficiency has a negative cost. That is, making a very efficient building can often cost less to construct than an inefficient one, let alone to operate. I live in such a house. It was slightly cheaper to build with no heating system in a climate in the Rocky Mountains, 2,200 meters up, where at that time it went to minus 44 Celsius on occasion. But inside we've grown 81 banana crops, passive solar bananas, with no heating system. And the reason it's cheaper to build is that you save more construction costs leaving out the heating system than you pay for the efficiency that gets rid of the heating system. The same thing works fine in, say, Bangkok. Everyone in Australia lives in a climate somewhere between Bangkok and Old Snowmass, Colorado, so that's rather an encouraging example. I have a...
And by the way, I've been to your wonderful house. It's beautiful apart from being incredibly efficient.
Yeah, it's really fun to sit there leaning forward for mangoes and backward for papayas and while it's blizzarding outside and you know you're not stealing from your kids. Or I drive a carbon fiber car from BMW, electric car, that's quadrupled efficiency, but it doesn't cost extra because the carbon fiber that makes it so light and is supposedly too dear to use is actually paid for by simpler manufacturing and fewer batteries to move less weight around. Or let's take an industrial example. Half the world's electricity runs motors, half of that runs pumps and fans. But if you make the pipes and ducts that the pumps and fans move fluids through fat, short, and straight instead of thin, long, and crooked, the friction goes down 80 to 90 odd percent, 97 in my house. And the result of that is that if everybody did it, you'd save about a fifth of the world's electricity. Or if you then leverage that into new, tiny, very efficient motor systems to meet the reduced load, then you'd save about a third of the world's electricity, just in that use of pumps and fans.
Yep.
Well, none of this is in our climate models or our government studies or our industry forecasts. There's only one engineering textbook published in Australia in 2009, I fear it might be out of print by now, that even mentions this approach. And you know, I teach it at Stanford, but it isn't widely taught or practiced. And why not? Because it's not a technology, it's a design method.
Yep.
So design, the way we put the pieces together, is really the key to a lot of the cheap savings, and yet most people don't think of design as a way to get to speed and scale rapidly.
I think your point too about if you don't have efficiency in the end use as a focus, then you also use enormous amount more resources, and it puts pressure on supply chains and skills and everything.
If you have inefficient cars, and also if you live in patterns that cause you to jump in a car whenever you need to go anywhere, instead of being already where you want to be, all of that uses more battery minerals.
Sure, and more maintenance on the roads, and on it goes. How do we get people to do this sort of system thinking? Because one of the things that you pointed out yesterday at your workshop, and I've seen it so many times, is that you ask an engineer to do an efficiency study, and they end up with a menu of discrete items with a payback period against them. They often don't look very attractive, and then they add them up and it looks less attractive, and they don't never look at the entire system's opportunities. How do we change that around?
Well, educate engineers differently and educate their clients differently to demand that they look at the whole system, or you hire a different engineer that will. If, for example, you have this list of ways you can improve a building efficiency, and you combine all of them, well, the lower cooling loads because you have more daylighting and more efficient lights and better insulation, better windows and so on. That lets you save a lot of mechanical equipment that can about pay for everything else. So what looked like maybe a 10-year payback suddenly becomes 1 year.
Yep.
Because you're doing the whole lot together and capturing the synergies between the parts.
I saw when you're doing a workshop, it's quite interesting just watching people's faces. There's a lot of aha moments, like, "Ooh, I've seen that myself." One of the things that having been in the field almost as long as you have, Amory, and I asked you this when I was over in Aspen, when you the point that you made about there being an abundance of stupidity and that being a very unlimited resource, how do you keep optimistic? Because I just see stuff. When you consider how much we could have done over the last 50 years that you've been in this area, 40 years that I've been in it, I can't help thinking, if we could have done the things that that were possible over that time, we would have this climate change would not be even a big issue for us. How do you keep optimistic, and what's the?
Well, I'm not actually optimistic or pessimistic. Those are different sides of the same coin, which is a kind of irresponsible surrender to fatalism, as Dave Brower put it. I live instead in a spirit I call applied hope.
I like that.
Yeah, as opposed to theoretical hope or mere glandular optimism.
Yep.
There was a Welsh development economist who said to be truly radical is to make hope possible, not despair convincing.
Yep.
And there was a lovely sort of Taoist remark by a chap called Michael C. Muhammad, whoever he is or was, who apparently said or wrote, says the internet, everything is going to turn out all right in the end. If it's not all right now, it's not the end yet.
Yes, I love
Don't
that.
let it bother you, just keep on going.
Yeah.
So, Frankie LePay said that hope is a stance, not an assessment, but it's a very good stance to come from.
I love that. So it's a philosophical position.
Yeah.
No, it's very good. And do you have?
And it stimulates you to make choices all the time that help create a world worth being hopeful about. So it reinforces itself in this virtuous spiral.
And when you look at the sort of immense climate challenge that we've got now, it seems to be worsening by the day. How do you, when you apply your applied hope, do you think we're going to come out of it okay?
Well, as the late Dana Meadow says, we have exactly enough time, starting now.
Yeah, I like that too. And what do you think is the most important approach that we need to have here to sort of keep focused and conquer climate change as an ongoing problem?
Well, we've got the right amount of carbon, but it's in the wrong places. It should be in the soil and the standing biomass like trees, and instead it's in the air and the oceans, so it's out of place. To get the carbon in the right place, we need to enjoy the extraordinarily rapid now transition towards renewable energy, first for electricity, and International Energy Agency now says that by 2028 will be about 42% renewable electricity. And Australia's already at what, 40?
Yeah, mid-30s, yeah.
Mid-30s, okay. South Australia, 75.
Yeah, more than that, yes.
And within a few years, 100. But also efficient use. And we found in the U.S. that quadrupling the efficiency of using electricity would cost only 1/10 as much as the electricity it saves. So just quadrupling efficiency isn't nearly enough. We should have bought more than that. I think if people pay attention and ask, why are we doing this thing at all? Why are we doing it in this way? Why does it use so much energy? You could actually do almost everything with almost nothing by designing properly.
Yep.
And we ought to insist that our designers do that and reward them when they do. Reward them for what they save, not what they spend.
How do we train our engineers, architects, and the others rapidly so that we can get them to make sensible decisions going forward?
Well, differently than we do now. And I'm trying several approaches to this besides my teaching at Stanford. I'm seeding that around the world. Lately, for example, in Australia and India, and you know, China and India each graduate about 1.5 million engineers a year, and we've already set up in India to spread this approach to 3,000 technical higher ed institutions. We're about to do something similar in a different way in China, and to get some materials to the chief engineers of the 17,000 biggest factories, who will then start competing with each other to apply it. Well, I think this is going to spread rather quickly because they're so competitive and have very clever people, and Australia needs to catch up if it wants to compete in that sort of world where the real advantage comes from efficiency. I'm also going to put my lectures online. We're making arrangements for that. And I think there are a lot of engineers of all ages and other designers who will find the material intriguing enough that they will really be tempted to try it. Maybe the most fun part of it is that you can get a lot of super efficient design without going back to school to learn any new theory. It just shows up in, say, a picture of a pipe layout, and any plumber or pipe fitter can look at it and understand what it does and say, I could do that.
Yep.
Then they can go do it, and I think provide much better value.
Well, I certainly intend to bring your integrative design course to Australia. So I think we're getting near the end of our time, but I just want to finish off maybe by asking you, what are you most proud of about your career to date? Obviously, you've still got plenty of years to go in this, but you know, what do you feel is your greatest achievement?
Oh, probably redefining the energy problem in '76, and if I could be permitted another one with a couple of co-authors, redefining capitalism in '99 in a book called Natural Capitalism.
It was a great book.
Yeah, thank you.
Well, thank you very much, Amory. It's been a pleasure as always, and again, very happy to have you in Australia, and
Pleasure.
I hope you get a chance to come again.
Thank you.